Welcome to part 2 of the Unit 2 review, where we'll continue reviewing the Unit 2 test. We'll start with question number 16. Number 16 is a simple rounding problem. The first thing you always want to do when rounding is figure out which place value you're rounding to. And in this problem, it's asking you to round to the nearest whole number. We've talked about the nearest whole number. The nearest whole number is a particular place value. It is the ones place. This is your nearest whole number because it is the closest whole number to the decimal. The numbers to the left of the decimal are all whole numbers. And the numbers to the right of the decimal are fractions of a number because as you read them as tenths, hundredths, and thousandths, which you would write 1/10 as a fraction, or 1/100th as a fraction, or 1,000th as a fraction. So all the numbers to the right of the decimal, because the way you read them, are fractions. They're not whole numbers. And if you recall, when we compared decimals, the first thing I asked you to do was circle all the whole numbers. That's all the numbers in front of the decimal, and compare those first. So that's a reminder that your whole numbers are to the left of the decimal. Now the closest or nearest whole number is always the ones place because it's closest to the decimal and it's a whole number. So here's an example problem, 246 and 934 thousandths. First thing you want to do when rounding this to the nearest whole number or to any place value, this will also work for question number 17, the nearest whole number would be the ones place. The first thing I want you to do is underline that place value and then draw an arrow to its partner. Its partner in this case is telling the 6 to go up, or as the analogy I've been using, to keep swimming. If you're halfway across the pool, you would continue on. So 9 is almost at the end of the pool or almost to the next number. So we're going to round this up and turn that 6 into a 7. The 6 becomes a 7, and everything after that 7 becomes a 0. Everything before that 7 stays the same. You can decide at this point whether or not you need these zeros. We don't really need them. So you would take them off, and your final answer would be 247. I'm going to use the same number here to represent number 17. 17 asks the question a bit differently. It asks you to choose the digits that show 3 and 96 thousandths rounded to the nearest hundredth. So you'll need to round this number off to the nearest hundredth with a TH, and then choose from these numbers to write the appropriate answer. Just write your answer basically, and if you have an answer that doesn't have a 2, 3, or 4 as a whole number and one of these digits as your tenths and hundredths place, then you've done something wrong. You should look at your work. Using 246 and 934 thousandths, I will show you what this would be if I asked you to round it to the nearest hundredth. First thing you would do is underline the hundredths place. Then you would draw an arrow to its partner, always to the right. The partner is telling you one of two things. Either the 3 will stay the same if you're not halfway to the next number, or it will go up to 4 if you are halfway to the next number. The 4 is not halfway to the next number, so the 3 is going to stay the same. So bring that 3 straight down, or write the 3 down, and everything after the 3 will become a 0. Everything before the 3 will stay the same. That includes the decimal. And here you have your final answer, 246 and 93 hundredths. I'm going to say hundredths and get rid of that 0, so I don't have to say 930 thousandths. Number 18 is going to be using the same number for all of these problems. It's going to be 5 points possible. You're going to take this number here and round it off to the tenths place and put the letter that belongs to that answer in the correct box. You can see then, therefore, if you miss one of these, you're going to miss at least 2 of them. So it's going to be important that you focus on each one. You show your work for each one. You should be writing the number, 143, 649 thousandths, underlining the place value to begin with, the tenths place. Show me your arrow, and continue to solve this problem, and then go find the answers. I'll repeat, there needs to be work for each one of these. I want to see this kind of work for each one. So I should see this thing rounded 5 different times to 5 different place values. Numbers 19, 20 are just simply straightforward add and subtract decimals. They've already lined up the decimal for you. That was wonderful of them. Number 21 and number 22, you're going to have to estimate. And since it doesn't tell you how to estimate or what place value to round it to, then you're going to just estimate to the nearest whole number. We already have discussed where the nearest whole number is. So you're going to need to put an equal sign next to both of these and write down the new estimated amount. I'll give you an example problem. In this problem, you would round $32.45 by underlining the nearest whole number, arrowing to its partner. Partner tells the 2 to stay the same. The 3 in front of it will stay the same, and everything after it will become a 0. That will round off to $32. The $4.65, you will underline the whole number, round or put the arrow to its partner. Partner is telling the 4 to go up. This will become 5. Everything after will be a 0, including that decimal. Everything in front will stay the same, and there is nothing in the front, so it rounds off to $5. We're going to add these two, and you should be able to do that in your head now. $37 is what you get when you estimate those two amounts. You'll do the same thing for 21 and 22. Make sure you pay attention to the sign. Number 21 is a subtraction problem. You don't have to put your answers in the box here. If you do, though, make sure that you number them 21 and 22. That way we can spot your answers easily. Numbers 23, 24, and 25 are all word problems. Question number 23, the distance around a park is 308 and 94 hundredths of a meter. Nikki runs around the park twice to catch her dog. How many meters does she run? Immediately, we're dealing with a park. Somebody's running around the park. In my mind, I'm thinking circle. And that circle all the way around is 308 and 94 meters. And she's running around that circle twice. They want you to let us know how many meters is she running all together. Using those keywords, and this is a very simple diagram, and you might want to put a ×2 there, or create 2 circles representing each time she went around it. Using that model and your knowledge of keywords, figure out how many meters she traveled in all. It says to explain why your answer is reasonable and draw a model to show how you solve the problem. Well, a model could be something simple. It could be anything that helps you solve the problem. So a couple of circles labeled properly could be a model. You also do need to explain in words why you think the answer is reasonable. And the easiest way to do that is simply estimate. If you estimated 308 and 94 hundredths off to the nearest whole number, you would be awfully close to the real answer. That would be a great estimation. You could even round it off to the very first digit, the 3, and still get fairly close and know that your answer is reasonable. So choose how you want to explain why it's reasonable. Number 24 is a multi-operational problem. It's a lot like the math attacks we do. You're going to be buying a skateboard and a helmet. It's tax-free day, so you don't have to worry about figuring out how much tax there is. The store gives Ray a discount of $18.50. Discount means you're saving money. Ray gives the clerk $150, and you're supposed to tell us how much change he's going to get. So you will need to subtract the amount that he's spending from the $150. First, you'll have to figure out how much he's spending, and that requires multiple operations. I'm going to allow you to work this problem on your own. There isn't a lot more I could do for you, but realize that you're going to have to find the total amount he spent and subtract from that how much his discount was so you know the real total amount. And then you'll have to subtract that from the amount he gave them so you know how much change there's going to be. It says explain why your answer is reasonable, so again, you can quickly round these off. 89.98 should be rounded off to the nearest whole number. 4485 could be rounded off to the nearest whole number. You could round 1850 off to the nearest whole number and work with them mentally to find out if your answer is reasonable. Please explain in words again why you think it's reasonable. Explain what your estimated answers were. 25 is asking you to estimate how much faster one student is than the other at the 100-yard dash. One student, though, is running the 100-yard dash in 12 seconds, 12.19 seconds. Another's doing it in 12.38 seconds. They're very close. It says first to estimate and then find out how much faster the first place runner was. If you were going to estimate this, it would be something that you wouldn't want to estimate to the nearest whole number because you would end up with the same whole numbers and there would be no difference. They're not even a second apart. So you'd want to estimate to the first digit that's different in this case. So the first different digit is the 1 here, which would round up to a 2, and the 3 here, which would round up to a 4, and that could tell you an estimate of what the difference is. But you need to find the exact answer as well. And you want to find the difference, and difference is one of those key words that tells you what to do. Check the back math board if you need to see that. An explanation as to how you found your answer here is probably not that necessary if you're showing your work. More rounding for number 26. You just have to say yes or no. Is this rounded correctly? Is 245 and 6/10 rounded to the ones place, does it equal 246? And if it does, yes or no. There will be 1 point for each of these. Show your work again. You're rounding them off, you have to do that. So underline the correct place value, the ones place. Show me the arrow to its partner so that I can see that you're rounding properly. Number 27 is asking you to fill in a table with the amount of rainfall each day. Some of this table is already filled in for you. We start with the first line. Shayna takes measurements of rainfall for a week. She measures 2,400 centimeters on Monday. Monday's not listed here, so you need to fill them in. Monday should go here, the day after Sunday, and you should fill in 24 hundredths of a centimeter. Continue to fill in the rest of Tuesday and Friday, and Thursday you could write in. Obviously nothing on Thursday. And Saturday is done for you. There was no rain on the rest of the days, it said, so there would be no rain here. So we only have rain to fill in on Monday, Tuesday, and Friday. Fill in the rest of this on your own and meet me back here for part B. So we're back here for part B. There's a giant fraction bar here, and it's telling you that this fraction bar represents 1 centimeter. Of course, it's a lot longer than 1 centimeter in real life even, but okay, so we're blowing it up, and it's supposed to equal 1 centimeter. And you can see that they've broken this 1 centimeter up into parts, and if you look at the dark lines here, and you were to count each of these dark lines, you could see equal parts, probably 10 of them. And within each tenth, like these are tenths, there's 10 of them. That equals a whole. 10 over 10 would be your final count, right? 1/10, 2/10, 3/10, 4/10, 5, 6, 7, 8, 9, and 10. And within each tenth, there's 10 more parts. So really, if you counted them, there would be 10, 20, 30, all the way till you get to the end, which would be 100. There are 100 equal pieces total. So each of these smaller pieces are 1/100ths. Well, it's asking you to shade the bar to show the total rainfall Shayna measured. Well, you will have to go back to the previous graph and add up all the rainfall. Once you have a total, you can shade it in. The total will probably be in hundredths. And so you could just shade in the total number of hundredths that you have. Let's just say, for example, the total was 42 hundredths. You can look at this two ways. You could say, okay, well, 4 of those are tenths, so if I shade in 4/10, that would be this amount. And then 2 of them are hundredths, so I should just shade in 4/10 and then 2 hundredths. Or you could look at the whole thing and read it as 42 hundredths and shade in 42 of these little tiny hundredths. So you'll have to go back up and total the amount of rainfall Shayna logged and then shade in the correct amount. Number 28. A lizard's body is 2 45 hundredths of a foot long. The lizard's tail is 1 82 hundredths of a foot long. Part A says, how long is the lizard? Well, you have the tail and you have the body. Both those parts make an entire lizard, so simply add those two together and you will know the total amount of the total length of the lizard. Part B says, how much longer will the lizard need to grow to be 5 feet long? Well, if you look at these two numbers, 2 45 hundredths and 1 82 hundredths, you could tell that simply estimating these are not going to add up to 5. He's not 5 feet long, but how much would he need to grow to become 5 feet long? You'll need to figure out the difference. I won't tell you how to do that. I'll let you figure that out, but you can rest assured that if you add these or multiply these, your answers will be way too long. He shouldn't have that much further to grow. So check your answer for reasonableness to make sure that you've done the right thing. We're going to be skipping number 29. You can cross that out. Let's move on to number 30. Number 30 is a 4-point question. You should enjoy this question. The work is already done for you. You just need to check for accuracy. So this would be like what you've done on the rest of the test. You've done the problem already. Now you need to go back and double check, make sure the math was done correctly. Simply true or false. Is the answer correct or not? All signs are positive. You're adding in all of them. Always focus on the signs. On the test, it could be different. Congratulations on finishing the review and good luck to you on this test.